Hello, my wonderful students. You are welcome to another class today. We remember in our last class, we concluded discussion on applications of integration, where we looked at area under the curve. We looked at a particular curve where we have the curve both above the x-axis and also below the x-axis. And that brought us to conclusion on applications of integration. But in today's class, we are beginning a new adventure where we are going to be looking at composition and resolution of coplanar forces. We'll be looking at what? Resolution and composition of coplanar forces. Particularly, we are going to be looking at forces acting at the same plane. That's what coplanar forces mean. We'll be looking at finding resultants of two forces acting at a particular point. Both of them will be at a particular angle to each other. So that's a summary of what we are going to be looking at today. Let's get to class immediately and see the video I have for us today. Yes, our topic for today is composition and resolution of coplanar forces. Now we're going to begin with just definition of terms, exactly what we're going to be needing for this topic. Resultant force. What's a resultant force? A resultant force is a single force that represents the combined effect of two or more concurrent forces. Thus, the resultant is a single force that is very important for this topic because we are going to be finding resultant of a force. That's one primary thing that we're going to be doing in this topic today. Good, so we are going to be using parallelogram law in today's class. We all know what a parallelogram is, isn't it? What's a parallelogram? A parallelogram is one of the quadrilaterals. That's a four-sided shape. Good. Parallelogram is not strange to us. I believe so. Now, what's a parallelogram law? Parallelogram law is simply talking about we represent the two forces we are talking about using the two adjacent sides of the parallelogram, and the resultant is represented by the diagonal of that parallelogram emanating from that same point where we have the two forces. That's just the summary of parallelogram law. So we're going to be employing the parallelogram to represent the sides of parallelogram to represent our forces, and the diagonal will represent the resultant, and that's basically what we are going to be doing today. So these two terms, resultant force and parallelogram law, they are very, very crucial for the understanding of today's topic. Now let's quickly look at the sketch that represents the parallelogram law. We have a diagram here. Yes, we can see this diagram is a parallelogram. We can see the two opposite sides are what? Parallel and equal. Good. We have a force B on one of the sides and force A on the other side, OR. So our OQ, we see our diagonal being represented with our R. That R written there is the resultant. Now this are the basic formulas that we need. We're simply applying something that looks like cosine rule. Remember the cosine rule we treated in bearing in mathematics. Very good. So R is the resultant in the diagram. To obtain our resultant, I told you the crux of the matter for today's class is for us to find the resultant of the two coplanar forces emanating from the point O, for instance. So our R is obtained by the a squared plus b squared minus 2ab cos 180 minus theta. Theta is the angle between the two forces, as you can see on the screen. Okay, and we can write it as r squared equals to a squared plus b squared plus 2ab cos theta. Now you notice that sign before the 2ab has changed to positive this time. That is when you are using the theta directly. But if you want to find use 180 minus theta, the sign before 2ab is going to be negative. That's the difference. Now looking at this, to find alpha is the inclination of the resultants to the force A or OR. So that is going to be, we are simply using what we call SOHCAHTOA. That's opposite over adjacent. If you look at triangle OQD, that's QD all over OD. So to obtain that, our QD is represented by B sine theta using what? Using our SOHCAHTOA, B sine theta, and for OD we have the force A there, and to find my RD using my SOHCAHTOA, I have B cos theta. I believe every one of us can do that. Remember SOHCAHTOA, very good. So tan theta is simply to obtain, tan alpha rather, is simply to obtain the inclination of the resultant to the horizontal force there. So don't forget, these two formulas are very, very paramount to our discussion for today. So let's quickly look at an example very quickly. Now we have this question. We are seeing the question on the screen. We are given magnitude of force P and Q as 8 Newton and 12 Newton respectively, and we are given the angle in between them to be 40 degrees. We have to find the resultant force. Let's see how we prefer solution to this particular question. Good. I hope you are following. Very good. Now look at this diagram. The first thing we should do is to make a sketch representing our forces. We see we have a force, that's A there. We have another one, B. Okay, now let's look at that's the kind of, our B is 8 newtons and our A is 12 newtons. I'm using my B to represent my force P and A to represent my force Q. Very good. Now the angle in between them, theta, is 40 degrees. Now let's see how we solve. You remember the formula I gave you. We have 8 squared to get the resultant. 8 squared plus 12 squared minus 2 times 8 times 12. We put our cos 140 degrees. That's the angle between OR and RQ. That will give us 140. Do you remember co-interior angle? If I want to get ORQ, that angle there, remember we have to remove theta from 180 degrees, and that's how we got 140. If I remove 40 from 180 degrees, remember that is going to give us 140 degrees. So that's the reason why we have cos 140 degrees there. Now if we simplify further, I have what I have on the screen. My cos 140 has now become cos 40 degrees. So simplifying, I have my resultant to be 18.84 Newton. So that's our resultant. But let's get the inclination of that resultant to our horizontal using tan alpha as given. So we have 8 sine 40. This formula was given before. Just substitute 8 sine 40 all over what we have, 12 plus 8 cos 40. Remember the formula. Okay, very good. So if I simplify this, it's going to give me tan alpha will be equal to 0.28. And finally, my answer, how do you think we're going to get our alpha from here? We find arctan of 0.2836, isn't it? I believe every one of us can do that, because that is just an easy thing for every one of us. So if I find my alpha now, my final answer is going to be alpha is equal to 15.83 degrees. So that is the simple solution to what we have, the question we have for today. Thank you for your attention. Till we meet again in our next class. I hope we find the class very interesting. Yes, you're welcome back, my wonderful students. I hope we enjoyed the class. Did you notice that in finding the resultants of two forces acting at a particular angle and acting at a point, we use something like cosine rule? Good. That's exactly how to find the resultant of two forces acting at a particular point. See you in our next class. In our next class, I'm going to be showing you how to find resolution of forces, or how to resolve forces into both horizontal component and vertical component. Till then, take care of yourself and have a nice day till we meet in our next class. Thank you.